logarithms different bases, and we are going to use these formulas for the solutions. And if you remember the formulas here, if you switch the base and argument, you should write over the denominator, and the power of the base comes as a 1 over n, and logarithm AB can be written with different base, different than A and B, like C, logarithm CB, the numerator becomes C, denominator becomes A. Okay, logarithm 2 x plus logarithm 8x is equal to 8. We can solve two different methods this question, but the easiest one is here, logarithm base 2x plus logarithm base 2 to the power of 3 x is equal to 8. It's going to be logarithm base 2x plus 1 over 3 logarithm base 2x is going to be equal to 8. If we collect the terms to here, these are common terms for the addition. Here we have addition, logarithm base 2x bracket, if we get, parentheses, if we get, when you take logarithm 2x here, you left 1, and when you take logarithm 2x here, you left 1 over 3. So it's equal to 8. And if you continue from here, logarithm base 2x times, it's going to be here 3 times 1, 3 plus 1 is equal to 4 over, the denominator is written again, is going to be equal to 8. Then we are going to logarithm 2x, it will be equal to 8 times, this goes numerator, and this one goes to denominator, 8 over 4, it's going to be 8 and 4, if you simplify, this is going to be 2, this is going to be 1, logarithm base 2x, it's going to be equal to 6. So the answer is going to be equal to x is equal to 2 to the power of 6, 2 to the power of 4 is equal to 16, 2 to the power of 5 is equal to 32, 2 to the power of 6 is equal to 64, it's going to be, so x is equal to 64. If we continue with the B, here all the bases are different, it seems same, but for x here 16x, so they are not same, but the numerators are same. So it's going to be like this. We are going to use the property what is written here. We are going to use this property, the first property we are going to use here, and it's going to be 3 times 1 over the base and the argument we are going to switch, and it's going to be 4x plus 2 times 1 over logarithm base 4x plus 3 times logarithm base 3 times 1 over logarithm base 4 for 16x this time is equal to 0 going to be. Here if we arrange this one, 3 times 1 is equal to 3 over logarithm base 4x plus 2 over logarithm base 4 times x it is, plus 3 over logarithm base 4 16 times x it is equal to 0. Here 4 times x and 16 times x can be written as logarithm base 4 and logarithm base 4 16 plus logarithm 4x. So it's going to be equal to 3 over logarithm base 4x plus 2 over logarithm base 4 and 4 plus logarithm base 4 and x plus 3 over logarithm base 4 16 plus logarithm base 4 x is equal to 0. Here logarithm 4 equals to 1 and logarithm 16 is equal to 4 squared 2 times it's going to be equal to 2. We know that one. And instead of logarithm base 4x, I want to substitute logarithm base 4x by y or 3. Then we are going to make t substitution here. 3 over t plus 2 over 1 plus t plus 3 over 2 plus t, it should be equal to 0. All the denominators are different, addition between the rational terms, so I'm going to multiply with different bases. I'm going to write here 1 plus t, here 2 plus t, 1 plus t times 1 plus, I'm going to multiply 1 plus t times 2 plus t, it's going to be here. Here this is going to be t times 2 plus t, and here it's going to be equal to t times 1 plus t. We are going to multiply by these terms. If we continue from this part, here 1 plus, I'm going to change the color again. Yes, 1 plus 3 times 1 plus t times 2 plus t plus 2 times t times 2 plus t plus t times 3 times t times 1 plus t all over here t times 1 plus t times 2 plus t is going to be equal to 0. Here I rationalize the denominator. All the denominators, when you multiply this 2, this 3, you're going to see all they are going to be the same. Here, if the rational operation is equal to 0, it means that the numerator, it should be equal to 0. So here what is written here, the number what is written here, it should be completely this one, it should be equal to 0, because 0 over a is equal to 0. So this term is equal to 0. So it means that I'm going to continue a bit down because we are almost end here. This is going to be equal to t1, that's equal to minus 1 over 2. So x is equal to 4 to the power of minus 1 over 2. And that can be written also root of 1 over root 4, because the power is negative. 1 over root of 4, that's equal to 1 over 2. Or here, logarithm base 4x is equal to minus 3 over 2. That's equal to x x is equal to 4 to the power of minus 3 over 2. That's equal to x is equal to 1 over 2 to the power of 2 times 3 over 2, because 4 is equal to 2 to the power of 2 to the power of, if we continue like this, it's going to be equal to x is equal to 1 over 2 to the power of 2 is equal to 4. Pardon, we are going to multiply the powers only. 2 to the power of 2 times 3 over 2. You need to simplify them. That's equal to 1 over 2 to the power of 3, and x is equal to 1 over 8 it must be. Okay, here we have logarithmic equations with parameters. So we are going to solve in terms of a. It means that we are not going to find a value for the 3, 4 logarithm 1 over 2. We are not going to find one value. We are going to find x and a. Here we are going to, when we check, we are going to recognize here, as you see, all the arguments are same like in the previous question. So this is going to be 2 times 1 over logarithm base ax plus 1 over, we don't have any coefficient here, logarithm base ax plus 3 times 1 over logarithm base a square x, it's going to be, is equal to 0. This is going to be 2 over logarithm base ax plus 1 over logarithm base ax plus 3 over logarithm base a square x is going to be equal to 0. Here, if I separate them, this is going to be equal to 2 over logarithm base a x plus, to separate means these are in multiplication form, that's why it's going to be equal to 1 over logarithm base a plus logarithm base a x, it's going to be plus 3 over logarithm base a square plus logarithm base a x, it's going to be, here we know this is equal to 2, this is equal to 1, and if I say these are equal to y again, or t, if I substitute by t, this is equal to t, here t, and this is going to be equal to t, and here I forget to write 0. So the equation becomes again same, 2 over t plus 1 over 1 plus t plus 3 over this is going to be equal to 2 plus t is going to be equal to 0. And when we make the denominators equal, here I need to multiply these terms by here, this one by 1 plus t times 2 plus t again. I need to multiply this one t times 2 plus t, which is not here, 2 plus t, and which is not here, t times 1 plus t. I need to multiply these denominators, and if I continue here, one more time, if I continue from this part, here it's going to be equal to 2 times 1 plus t times 2 plus 1 plus t times 2 plus t plus 1 times here, 1 times, I'm going to multiply by 2 here by t, by 1, pardon, t times 2 plus t plus, this is 3 times t plus 3 times t times 1 plus t over, all over, t times 1 plus t times 2 plus t is going to be equal to 0. Like in the previous question, here numerator it should be 0, then it is possible. If logarithm base here, we replace t by logarithm base ax. Logarithm base ax, it should be equal to minus 4 over 3. Logarithm base ax is equal to minus 1 over 2. It's going to be, and x is equal to a to the power of minus 4 over 3, and x is equal to a to the power of minus 1 over 2 is going to be, and we have to write these conditions. X must be greater than 0. Here, a must be greater than 0, and a is not equal to 1. These are the conditions, because it was the base here, so a must be greater than 0, a must be different than 1, and x always, what is written to argument, it must be greater than 0.